Hello, this is Chelsea Fiddler, and this is my presentation for my FYRE project for Geography 120 with Alec Aiken. For my FYRE presentation, I chose to present the effects of rising temperatures on the Arctic glaciers, specifically how the change in average temperature in the Arctic affects the difference in Arctic glacier mass from 2002 to 2020. So what are glaciers? Glaciers are large bodies of ice that form over hundreds of years. Snow accumulates over time, and as the weight builds up, it compresses itself and turns into ice. These masses slowly move over time due to the force of gravity. Why are glaciers important? They act as a protective layer to the Earth. They reflect radiation due to the high level of albedo of the snow and ice, and this helps to cool the Earth. They provide a look into how climate has changed through time, since many Arctic glaciers are thousands of years old. What are the effects of melting? They cause a change in the oceanic currents, a rise in sea levels, change in the circulation of oceans, and melted glacier water rises above salt water, which affects the thermohaline circulation. So effectively, the saltwater levels are changed from the freshwater levels being added. So these pictures here show the change in Arctic sea ice from 1979 to 2021. So this top picture here is a satellite picture from 1979, and as you can see, the amount of ice and snow has drastically decreased in the picture here from 2021. These images were gathered using satellites to show the variation of sea ice, which is going to include glaciers. Over the past several decades, there has been a decline in sea ice annually. Each year, there is a melting and freezing season, and the freezing season has pretty much stayed consistent, but the melting season has grown on average since 1979, approximately 39 days. So for my graph, I did the difference in average annual temperature in the Arctic versus the difference in glacier mass annually in the Arctic. So as you can see on the bottom x-axis, I have the years from 2002 to 2020. And then on this y-axis here on the left side, you have the difference of the mass in the glaciers. So these orange dots represent that. And then on the right side for the x-axis, you have the difference in average temperature. So these points here are shown in blue, and they do vary quite drastically. So there is this trend line here in blue that shows that there is an increasing slope. The annual mean temperature was obtained by the Climate Research Unit at the University of East Anglia since the 1900s. This data shows a steep incline in the annual average temperature, which began in the 1980s and is continuing to increase. This data also compares the average change in Arctic temperatures to the average change in global temperatures. The comparison shows that the Arctic is warming at a greater rate than the global average, which started in 2000. Since 2002, NASA's GRACE satellites have been measuring the mass of glaciers in both the Arctic and Antarctica. These satellites measure Earth's gravitational field. Since water and ice are able to shift, they cause a shift in the Earth's gravity force. These measurements are used to measure the rates in which glaciers are shrinking, which is where this data here was obtained for the decreasing mass. And the mass loss in the Arctic is showing a near threefold greater loss annually than that in Antarctica. So in conclusion, while the rising temperatures are not the only cause of melting glaciers, it definitely has had a huge impact, which is shown in the graph. Humans have had a very negative impact on the world in the last 100 years. So the use of fossil fuels have drastically increased the amount of greenhouse gas emissions and have caused climate change across the globe, specifically seen in the increasing temperatures in the Arctic. The World Wildlife Federation estimates that even if humans were able to significantly lower their emissions in the foreseeable future, a third of the world's remaining glaciers will still melt before 2100. This has and will continue to affect not only the areas surrounding the Arctic, but the Earth as a whole, which we did see previously in slides, the effects from the melting, which will also include the fisheries and the coastal regions as well. So here's a list of the references from which the information was obtained.